Hello. Welcome to this session, folks. Uh, for the first talk in this session, we have a talk about Reinventing the Wheel by Jonathan and Barry Warsaw, who are working on the Wheel Next initiative and, well, the book work at NVIDIA. Please give them a warm welcome.
Welcome, everyone. We can't really see anybody. Lights are in our eyes, but so yeah, we're going to be talking about this Wheel Next initiative. Jonathan over here, he'll take over in a few minutes, and I'll get things started. We do both work for NVIDIA, but this is really a community-driven initiative that spans all of the entire Python community. These are all the folks from the GitHub. Lots and lots of people have contributed and have discussions. So it's really open to everybody. Before we kind of get started into the meat of what Wheel Next is all about, let's take a step back and celebrate the wins for the Python packaging community so far. This was a screenshot of PyPI a couple of weeks ago when we were putting the slides together. So you can see there's like tons of projects, releases, files, and users. This is PyPI stats, also from a couple of weeks ago, which is just showing numbers that I don't know about you, but it certainly blew me away. 1.6 billion downloads a day, 20 billion downloads a month. That's a lot. This is a graph that we grabbed, and you can just see it's just growing exponentially over time. And this is a screenshot from Fastly's plenary last year, and they shared some numbers, that go through the CDN, and it's just a prodigious amount of data and packages that are being vended by PyPI. So I think there's no question that Python packages and wheels in particular have been hugely successful, right? Like, people are using it every day in many, many different ecosystems in corners of the Python world that we're not even aware of. And for the most part, it works pretty well. The other thing to keep in mind is that this is the culmination of decades of work by many, many people, input and sponsorship by tons of companies and individuals over the years. And as we've seen, Wheels pretty much serve the needs of most users most of the time. So that's awesome. But as more and more use cases come up, and as more and more Python reaches more and more of the developer community, some of those cracks are beginning to show. And we're going to talk about some of those and some of the proposals that are coming out of the Wheel Next initiative. So what exactly is Wheel Next? My elevator pitch for Wheel Next is that it's an incubator for thinking about the problems and the solutions of the packaging community for the next, let's say, 10 years, 5 years, 30 years. It's a completely open source and open initiative. We use the term reinventing the wheel, although it's much broader than just the wheel format. We're really talking about evolving the Python packaging ecosystem. And as I mentioned, there's lots of companies, organizations, and individuals that are participating. But also, if you think about it, there's stakeholders. Users are obviously a huge cohort of stakeholders. There's tool makers, environment managers, installers, package managers. Tons and tons of different tools are consuming Wheels. We have consumers, we have producers, people building packages and uploading them to PyPI. So tons and tons of people are using Wheels, and so are affected by both the things that work well and some of these new challenges that are coming up, or maybe not even so new challenges. I will point out that on the slides, we're going to have lots of QR codes. So if you want to participate, just take a picture on a random slide, and that'll get you to both our GitHub and the wheelnext.dev landing page. So again, these are just a sampling of some of the communities and projects that are contributing and working with us or working together on Wheel Next. Obviously, it is rather, scientific computing, or however you want to say it, focused, but that's just because I think the packaging ecosystem doesn't serve their needs quite as well as many other communities. So a lot of the inspiration for Wheel Next has come out of this PyPackaging Native website. And if you haven't visited that, I highly recommend it. It's got a lot of really excellent detailed information about the problem space that we're trying to solve. So the way we sort of think about it is PyPackaging Native talks a lot about the problems, and then Wheel Next is trying to explore some of the solutions for those problems. But if you think about it, things that Wheels and pip and all those tools don't really handle very well are things like GPUs, where you have to have the right version of the package for the GPU hardware that you have, or even CPU microarchitectures. So it's not enough to just say x86 or ARM, but there are certain times when you want to really target a microarchitecture of those platforms. And then things like linear algebra libraries or other specialized libraries, there's no real way to sort of, identify those operating environments that you want to install the wheels on. Some of the other problems that come up are like wheel hosting sizes. There are hard limits and soft limits on the size of the wheels that you can upload to PyPI, and so we need to address that. And of course, native dependencies. These are native libraries that get compiled in whatever language, C, C++, or Rust, and it's very difficult often to specify exactly what you're looking for. So a set of axioms that we work from, that Wheel Next as a community work from, and these are all on the website. If it works for you now, great. It'll continue to work for you later. We're really not trying to change the experience for the vast community of Wheel consumers that for which it all works. We're really prioritizing the user experience, thinking about that first. What does it look like to pip install a thing or UV install a thing? And where there is complexity are, preferences to push that complexity into the tooling. And we want to meet users where they are, right? So we don't want to create another silo or another ecosystem that you then have to go learn and interact with. You're already using tools. You've got tons of tools, and you know which ones you prefer. That's where we're going to meet you at. And this is really ecosystem-wide. So we're not going to be promoting a particular tool or service. You think about even PyPI, there's lots of third-party indexes that exist, commercial indexes, tools all over the landscape, and so this is really thinking about how are we going to standardize what we need to standardize for interoperability. As I mentioned, we're prioritizing backwards compatibility, but if we have to break something to improve the experience, we're going to do so intentionally and explicitly with a very defined migration path for everybody, because we recognize that it's a very, very long tail. It's much longer than Python. If you think about Python's sort of lifetime of 5 years-ish for any particular release, you can think, well, T-strings, for example. I can't use them now, but I'll definitely be able to use them in 5 years when the minimum version of Python supports it. It's not that same way. It's much longer in the packaging ecosystem. So I'm going to turn it over at that, and Jonathan will take it from here.
Thanks a lot, Barry. So let's do a deeper dive on the problem that we'll next try to address. And then we'll follow up on what we try to do about it. So as Barry said previously, one of the biggest problems that the community has is PyPI, which is the default registry and repository for Python artifacts, has default limitation in place. And if you want to exceed these limitations, you have to ask the PyPI staff to bump them for you, which creates a lot of difficulty, a lot of time, and consume a lot of bandwidth for everybody. Aside of this, not only the package size has a specific limit, but the entire project at once. So you kind of boxed in by multiple limits at the same time, which creates difficulties when we are shipping these large AI or scientific computing packages. One solution to avoid these quotas is to have your own index. So essentially, I'm going to host myself my own packages. That way I control the maximum space that I allocate for my package. Well, that doesn't work as well as we would wish, mainly because the interface when you pip install package is not that great when you have to specify, let's say, 5 different indexes, and it can create security issues where multiple people can register the name NumPy, for example, and then the resolver is going to try to resolve by version priority, so find the best version somewhere. And in terms of security, it's difficult to manage. So improving the way that we can resolve and prioritize different indexes would be a high target for We'll Next. At the same time, as Barry was explaining, we are trying to fix and address a lot of the problems inside the packaging ecosystem in a backward compatible way. We try to reinvent the wheel without reinventing the workflow. And this is difficult as the wheel format as it currently stands does not allow non-backward compatibility changes in a way that we can express. If you have an old version of pip, for example, pick this, and if you have a newer version, pick that instead. It's kind of difficult to make major changes, such as symlink support and Z-standard compression, which would address in part and help to reduce the size, and metadata.json, which would be very useful for log files and environment resolution. Shared libraries. So as you know, a lot of the scientific compute space relies on binaries. And if you look at the entire space, we might load open blasts, for example, 5 or 6 times in the environment. And that's, not only we load it, but we also ship it 5 or 6 times, which is less than ideal. And we would like to have an efficient way to be able to share common DSOs to better promote interoperability, safety, and robustness throughout the ecosystem. A default extra, so that's maybe less of a scientific compute focus, but if you deal with libraries that have different visualization backends, or a web server backend, or GUI backends, this is a pretty common kind of design. Is my application support PyQt, or support Tkinter, support Matplotlib, or something else? I don't really care which one you pick. I just want you to pick one. And in the same way that a Python function allows you to have a default value for an argument, we would like extras to be also having a default value. If you don't specify anything, please use that. At least that will give you something functional. If you specify something else, well, like a default value, don't pick the default. And lastly, this one is about specialized hardware. So this is more targeting high-performance compute and scientific computing. It's about being able to select a package like NumPy, like Torch, like VLLM, that has been compiled and specifically built and optimized for the specific architecture that you have, the specific platform. If you install on a server, it shouldn't be the same as if you install on a laptop, because it doesn't really make any sense. And if you do end up not having fine-grained selection, what you end up having is the lowest common denominator, which is optimized for nobody. So this is another vertical that we are trying to address in the We'll Next space. That has been solved a little bit, in some ways by PyTorch, also JAX and the Rapids community, by having this sort of website selectors that force you to read the documentation. And this is awesome, because it allows us to do what we need, but it forces you to read the docs, to set a different index, and we are a little bit sad that this is the best answer we have today, and we wish we could do better than this. So let's jump into the proposals. I would like first to make a stop at a few honorable mentions. We only have 30 minutes today, so we're not going to be able to explore the entire scope of Wheel Next. So I would like to start by PEP 759, which is external wheel hosting. So this one tries to address the fact that people host artifacts on different repositories, but it's hard to know which artifacts comes from which repository. So PEP 759 would help to address that concern and at the same time reduce the burden on PyPI.org because the hosting and the serving would be distributed across the ecosystem in a better way. Default extra, I think I explained it already pretty well. It's about providing a default value for extra environments. How to reinvent the wheel? I think you could think about this one as a meta PEP. It's really about how to design the wheel format so that we can better support major iteration for the future. So it's a PEP about how can we make better PEP, how can we evolve the wheel format so that the next PEP doesn't have to do a backward incompatible change. Symlinks into wheel, PEP 778, a big challenge. Not every OS and file systems actually support symlinks. But this is very important to share libraries and DSOs, so we're also working on that aspect. And PEP XXX, because we don't have a number for it yet. Build isolation bypass. This is really important to allow us to build extensions when there is ABI compatibility involved. So you have a specific PyTorch on your laptop, and you want to build an extension of PyTorch that depends on the ABI of PyTorch itself. So I'm going to transition quickly to Barry for PEP 772 to talk to you about the governance PEP.
Yeah, so we've talked about this here at PyCon in the Language Summit and in the Packaging Summit, so some of you may be familiar with this, but one of the things that we recognize is typically with Python over the years, there's been as little bureaucracy as we can possibly get away with and more of a grassroots movement for handling things. And then as we find that we need some more formalism, we figure out how to do that. And so one of the things that we recognize is that it's about time now for a little bit more formalism in the packaging governance. Right now we have essentially two individuals who have a slice, a vertical slice of the packaging ecosystem, and they have standing delegations from the Python Steering Council. And anytime you have a bus factor of 1, it kind of makes you a little nervous, but it also means that there's a lot of burden on that one person to do everything and make sure they get it right. And so we're at a time where we're really thinking about how can we use the Steering Council model, which is mostly successful, and bring that into the packaging community so that the Steering Council could delegate packaging decisions to a packaging council that is elected by a large community of stakeholders in packaging. And so then they could really take the reins on packaging issues. So we're very close to solidifying what the governance process would look like. If you are familiar with the way the Python Steering Council operates and is elected, it's very similar. There are a few differences because of the nature of packaging and the reach of packaging, but largely we're at a point where we're trying to define the voting community, the community that will vote for the 5 individuals that will serve on the packaging council. Again, lots of discussions on discuss.python.org, and you can find the PEP by looking it up in the PEP repo. So we'll leave it at that. I'm hoping that sometime after PyCon, we can put the governance PEP up for a vote and get this going in the next, this year, potentially. So.
So let's jump to PEP 766 about explicit priority choices. So we discussed about the potential risk of having multiple indexes. The interface is not that great. We would like to better the way that you pip install package with multiple different indexes and be able to say PyTorch come from here, NumPy come from there, and the CUDA wheels come from there. That would be something that would be a great improvement from the user experience perspective, but we have to better the interface to ensure that we are not including security risk in the process, and namely by refining the way that we talk about index priority, index groups priority, and version priority. So this is more a PEP to define the vocabulary, the wording, than actually behavior, so that we can align the different installers on some commonalities around the behaviors. Native lib loaders, as I was previously saying, and Barry too, sharing DSO, so compiled binaries like OpenBlast, for example, is difficult. There is no safe way to do that that is common and standardized across the ecosystem. We want to find a way to converge to a sort of commonality, a sort of best practice type of approach that can be shared across the ecosystem. A sort of, if you can think about it, a sort of import lib, but specific around loading binaries. And as a lot of people like to say in Will Next, is good enough is better than nothing at all. And right now we have nothing at all. So we are trying to find something that can better the space. And last proposal that I would like to talk about is called We Have Variants. And I would like to talk to you about the dream that we envision at Will Next about what could the next iteration in Python wheel format could look like. So today, the platform, when we download a wheel, it includes Python ABI, so if it's 3.11, 3.12, 3.13, or 3.13 free-threaded, the OS, Windows, Linux, Mac OS, glibc, mini Linux, that's glibc, and CPU Arch, x86, ARM, PowerPC, and others. And what we try to argue is that this is not enough. We need more, and constantly adding new tags to better describe the platform is not a scalable practice. We're not going to add 600 tags today, 600 more in 1 year, and every year 600 tags. What about GPU computing? What about FPGAs? What about ASIC? And one day, what about quantum computing? We don't have the capacity to describe the platform as a whole today. We don't, even if we wanted to, we don't have the language to be able to do that. So Wheel Variant is very much about saying, well, I would like to install NumPy. You know what my computer is. You know which x86 64 version it is. You know which ARM version it is if it's ARM. You know which BLAS is installed on my machine. Pick the best you have, the best was compiled for my machine. Which what it is, find it, and install it. Same happens with JAX and PyTorch. You know which version of CUDA I have installed. You know which TPU I have available. You know which CPU instructions are supported by my CPU. Pick the best. And we really want it to be simple. So we have a prototype that we would like to share with you and potentially try to convince you to give it a try and give us feedback. It's really important for us to get feedback from the community as we are trying to build the tools that will support probably and hopefully the next 10 years of the Python ecosystem. So you can find the demo at variants-demo.willnext.dev. And I would really appreciate that you spend no more than 5 minutes trying the different prototypes that we have for you. So let's pretend we have an ARM v8.3a CPU on the machine, and we do pip install NumPy. So what the prototype is going to give you is that it's going to download an extension for your installer automatically, analyze the platform, and understand that this is an 8.3a ARM, and consequently reject 8.4a and 8.5a because this is not upward compatible, and download the right wheel, which is the best one, which has been perfectly optimized for the specific CPU microarchitecture that you have. But if you have an x86 64 CPU, and let's pretend that it's a V2, it's going to do the exact same. This time, it's going to reject V3 and V4 because it's not compatible. It's going to find the V2 artifacts, download it, and install it. What about GPU-accelerated packages like PyTorch? Well, the same happens. You download the NVIDIA extension to your installer, and the download of the extension is automatic. You don't have to do anything. As you just do pip install torch, detects which extension you need, and apply them to filter what is compatible and not compatible. So in this case, we have 12.8 CUDA, which means that CUDA 11.8 is not compatible. And it tells you the best you have for this machine is CUDA 12.8, please install it. If you do not have any GPU, well, the same happens. You need the NVIDIA extension to look at the system. It tells you don't have any GPU. Please reject the NVIDIA built artifacts. And consequently, nothing is compatible as a variant. Install the CPU build that is the default for PyTorch. So the prototype today supports PyTorch, NumPy, and XGBoost, the entire CUDA toolkit. And as build backend, we support Meson and Flit. Pip is the only installer right now that is supporting We'll variants, but we are working really hard with the UV people and the Conda community, Poetry, Hatch, and Scikit-build to broaden the scope and try to collect more feedback from different corners of the community. So as I said, it would be immensely helpful if you could spend 2 or 3 minutes trying the different tutorials, see if you like it, and give us feedback about what about X, Y, and Z? Did you think about this? How would you manage it? And I'm going to transition back to Barry for our final part of the presentation.
Yeah, so as Jonathan said, this is our call to action for all of you who are interested in participating, because it really is open to everybody and it really is a community effort. And everybody has their own use cases. So there's lots of ways to participate and engage, and we want to hear from you. So wheelnext.dev is the landing page. That's going to give you all the places that you can then take detours into your particular area of interest. That QR code will get you to the GitHub. I don't remember if it's the GitHub or the landing page, but you can get to both from either one. If you like Discord, you can get onto the PyPA Discord and join the WheelNext channel. And we've had a lot of presence here at PyCon. We've already had the language and packaging summits, so keep an eye out for the blogs, which summarize those events. And there will be sprints if you're sticking around for the sprints, which I hope you do because it's one of the most fun parts of PyCon. We'll be sprinting on WheelNext topics Monday through Thursday. No, Tuesday. Yeah, Monday and Tuesday. Jonathan has some amazing stickers, which you'll see in a second, and please come up and stick them on your laptop. They also have the QR code, and once again, variants-demo.wheelnext.dev is where you can try out the variant stuff. That's the lovely sticker that you can get, and that will have the QR code that will always get you there. And please join us. And once again, a few other QR codes that will get you there. The contribute.wheelnext.dev is links and resources for you to contribute back. That's our GitHub. It's all open source. And we have a mailing list, which we're using a little bit for providing announcements, so that will get you there as well. I think that's it. Yeah. I think we have 2 minutes, so maybe we can take a question or two. Yeah. There's microphones. Yeah, go ahead.
There's microphones over there in the middle, and we have about 2 minutes for questions. I think we can get 1, maybe 2. Please make sure they're brief and actually questions.
Hi. I know it's really nice that you're doing these variants based on what a current environment is or platform for a developer machine or a server, but what is the story for setting up a container? Like if you're setting up a Docker container and doing a bunch of pip installs, I don't really necessarily want to pick the variants for whatever machine I happen to be running on when creating the container.
So from our perspective, this doesn't really change from the situation of today. When you build a container, you kind of have to decide what wheel you're going to install into the container. So you're going to have to decide if you want something generic, so the lowest common denominator again. And the demo includes like -- no variants, which essentially go back to what is currently done today. And then you obviously have the possibility to create specialized containers for example, a specific BLAST version or a specific CUDA version. And we don't see this to be more of a problem in the future than it is today. Docker variants would be the answer to your question.
Thank you.
I'll just add on to that. The introspection of the system in which you're installing is done by these variant plugins or these provider plugins, and so you can override those or completely opt in, and you could say, you know, don't use this particular provider because it's not going to give you an accurate representation of what the environment the container is going to be in or the local development environment. What I really want is this other set of characteristics, and then all the other resolution for the exact variant will work just fine. A lot more information on the website.
Thank you to the speakers.